E, it cannot be E because 1 to 3 is plus 2, or you could say times 3. Okay, 3 to 9 is also times 3, but then 9 to 18 is times 2. So it's not a geometric. And it's not arithmetic because 1 to 3 is plus 2, 3 to 9 is plus 6. So it's not even the same number. So incorrect. Question 3, which one of these is the recurrence relation for this sequence? Again, Leon had trouble with this. I'm going to keep roasting you, man. First term is 3. Okay, T1 is 3. And to get the next term, I can say it's 3 to 6, which is times 2. 6 to 12 is times 2. 12 to 2, 24 is also times 2. So it has to be C. Okay. By the way, I remember as well that we haven't really seen a recurrence relation that looks like this. This just means 2 times Tn, yeah? It's the same thing as, when you have a format that looks like this. Two times Tn. Okay, it's the same thing. Or normally we would see it as this. Tn times 2. Same thing. Okay, it's exactly the same thing. Right. Shh. Kuzma, Jacqueline, are we listening? Okay, question 4, the 20th number of this sequence. So if it's a very high term like this, remember use your nth term rule. Okay, must use your nth term rule. Now if you forgot, actually can anyone tell me what is the nth term rule for a geometric? Say it, what's the nth term rule? It's Tn equals A times R power of n minus 1. Okay, that's the nth term rule. Use that guy for any high value term that we're looking for. Alright, and short answers. Okay, these ones here. Todio got this wrong, but we're looking for the 10th term. I know that my first number is 3, and you're multiplying by, what is it, Nathan? What are you multiplying by each time? Times 2. So that means for your nth term rule, it's going to be 3 times 2 to the power of 10, take away 1. And Benjamin, what did you get for this one?
1536.
1536, is that what everyone else got? Sounds about right, yeah. Sorry, so you're looking for the 10th term, not the 9th term. Oh, no, 11th term. Torio just put to the power of 10 there, so that's not right. Find the 5th term in this sequence. There's 2 ways you can do this. You can use either the nth term rule, or if you want, you can just use the recurrence relation and list out the next term. You can do that on your calculator as well, guys. So on your calculator, it says you know that the first term is 7. So if you type in 7, and then let's see, Jacqueline, what's the common ratio in this recurrence relation? Have a look here. What's the ratio? What's the number you're multiplying by to get the next number? I'm underlining. Yes, it's 2. That's your common ratio, right? So you start off with the number 7, and then you just press times 2. Just keep in mind that 7 is your first term, yeah? So when you press enter, 7, enter, times 2. If you press enter, so there's your second term, third, fourth, fifth term, yeah? Just make sure you understand what's term 1, term 2, term 3. And if you have term 0, understand that that's term 0, starting term. It's not the same as term 1. Okay, let's keep going. Question 3, a basketball dropped from a height of 48 meters. After each bounce, it reached only half. Okay, so when it's saying only half, that means you're decreasing it by half, or you're dividing it by 2 each time. Or your common ratio is 0.5, because it's going half each time. Okay, starting with a height of 48. So another key word there, starting. Starting term is 48, not term 1. Okay, with the 48 meters, list the next 3 heights that it reached after each bounce. So we're looking for the next 3 bounces, the height of each one. So if you use your information there, we know that the ratio is 0.5, because we know that if it's only bouncing half of its previous, you're multiplying it by 0.5 or by a half, or you divide by 2. Yes?
If you want to, let's say you're dropping it from 1,000 meters, right? And you don't want to do the long way. What could you do instead?
Nth term rule.
Okay.
But remember the nth term rule when you use V0.
What do you have to do then?
So if it's nth term rule for V0, so for something like this, you're going to do Vn equals V0 times R to the power of n. No more minus 1.
Oh,
If you're using V0.
okay.
Okay, so that means you use this guy. But if you want to do the short way with your calculator, okay, you can just do this. So the starting height is 48. So you start with 48 and then you're timesing it by 0.5 each. So there's term 1, term 2, term 3, and yeah. Oops. So 48 is your first term, yeah? I mean starting term, don't forget that. Starting term times 0.5. So this should be technically term 2. Oh, sorry, term 1, term 2, then term 3. I think it's asking for the first 3 only. Yeah. Okay, so just understand when you use this method, remember which one is which term is which for it. Do you have a question, Nate? No, okay, cool. All right, question 4, or you can use the nth term rule for that. Question 4, a sequence starts at 1000. Another keyword there, start. That means that has to be a V0. And each new term is 8% less. Okay? 8% less means the ratio that you're going to use is the decreasing ratio, which is this. Okay, the decreasing one. So R equals 1 minus percentage over 100, and there's the ratio. So if we're looking for the 6th term, so if you don't want to you do the long way, you can use the nth term rule for it, but just keep in mind that when you use V0, there is no more minus 1 for the n. Okay, so that's V0, that's R, and that's n here. Okay, just keep that in mind, please. No more minus 1. Alright, next one. Question 5. This one we didn't do a lot of in this term, but I think we kept it in to see if you guys could get it. So for graph A, it matches with C here, where the geometric and the ratio is 2, because it's multiplying by 2. So you kind of have to zoom in a little bit to see it properly, where you can see that each number, okay, to go to the next number, you know that this is 1, that's 2, 3, 4, 5. So 1 to 2 is, well, that's kind of like plus 1, but then 2 to 2, and then when, on the third number, you're at 4, it's doubled it, so it's plus 2, and then from 4 you've gone all the way up to 8. So that means if I listed this out properly for you guys to make sense of it, T1, T2, T3, and T4. This is another way you could do it if this is confusing. So T1, term 1 is 1, term 2 is 2, term 3 is 4, term 4 is 8. So you can see that it's multiplying by 2 each time. Okay, so it's timesing by 2. And I understand this was not going to be on the SAC, so don't be too scared of it. I don't think we'll test you on graphing. This one here, I can see, okay, here's an interesting thing, guys. What do you notice with a arithmetic and a geometric? What's the difference between both in a graph? You see, so if I look at this geometric sequence, okay, this kind of curves upwards. But what's interesting about an arithmetic like this? It's a straight line, okay? So understand the difference between that in a graph. Arithmetic, straight line. Geometric, it curves, either upwards or down. Okay, so here for part B, it matches with A, where it's an arithmetic sequence of the common difference of 2. So it adds 2 each time. For C, it's a geometric. You can tell it's geometric because it's going down in a curve. Okay, with that said, Daniel, is D, Daniel, if you have a look at D, is this going to be an arithmetic or a geometric sequence? Good, because it's a straight line. Okay, so arithmetic lines are straight, geometric lines are curvy. Alright, extended response, question 1. How many squares are in the 10th shape of the sequence below? So if you're looking at these shapes, how many squares are in the 10th shape? So if you have a look, I can see that you're starting off with 1 in shape 1, and in shape 2 you've got 5, and in shape 3 you add another 4, so it's 9. Okay, what's happening here? Is this arithmetic or is it geometric?
Arithmetic.
It's arithmetic. It's adding 4 each time. plus 4. Okay, so if that's the case, if you're just going to add 4, the interesting thing is you can either use the nth term rule for it, or you can also do the same thing on your calculator. Yeah, so if you write 1 as your first term, and then you're going to add 4 each time. So there's your second term, third, fourth, fifth, sixth, seventh, eighth, 9, 10. It should be 37. Okay, or you can use your nth term rule for that. If anyone remembers, does anyone remember the nth term rule for a arithmetic? So it's Tn equals, who remembers it? Yes, Andrea.
8 times half.
Ooh, no, that's the geometric.
That's geometric.
Yeah, yes.
A plus in brackets n take away 1 bracket and then minus the after.
Good, D. So this is for your arithmetic.
Oh, what's D?
D is common difference.
Oh, okay.
So this is what we learnt last term, sorry. Good try, Andrea. Thank you for trying. So this is only for an arithmetic sequence nth term. Don't get it confused with the geometric. Geometric's different. Okay? So understand the difference there. Slightly different. But you need to know which one is which so you can use it appropriately. Okay, shh. Let's go to the next one, part B. What is the number of the shape? What number has a shape of 81 squares? Okay, so using your calculator, which one will have 81 squares? So again, using your calculator for this, so we start off with 1, and then you write equals, and then plus. We're adding 4 each time, so this is shape number 2, 3, 4, 5, 6, 7, 8, 9, 10. Shh. Thank you, guys. And we're trying to get to 81. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the 21st shape will have 81 squares. Okay, 21st shape there will have 81 squares. Now, hopefully this won't confuse you guys a little bit, but if we try to work this out algebraically, and we use the nth term rule, so 81 equals 1 plus, so we're looking for the unknown number minus 1 times the common difference of 4. How do we solve this, guys? So remember, in this formula, this x represents that shape number. Okay, so how do we solve this? Anyone want to tell me? Get x by itself. So I'm gonna just swap this around so it looks nicer. So I'm gonna go 1 plus x minus 1. You don't have to know how to do this. I'm just doing this so that we can see how this connects to some algebra. Okay, so Emily, if I wanted to make x by itself, what would I move first here? The plus one. This one here. Yeah, so this one, yeah. So this is going to be a plus on this side. So if I move it here, what happens? Becomes minus, yeah. So you're left with x minus 1, 1 times 4 equals 80. Okay, what's next? Anyone want to tell me, what should I do next? Yeah, there is a 4 there, but what should I do with the 4, actually, before I even do anything with it? See these brackets? You should expand this first, because you don't want to do anything until you finish expanding everything. Okay, so I've expanded it. Okay, now what's next, Leon?
You gotta move the minus 4.
Good, so it becomes plus 4. You don't have to do this, okay? I'm just showing you now.
That is not gonna be on the stack.
It's not going to be in the sack, not this. You'll probably just use your calculator for this, like what we just did with when you keep pressing enter. It's easier, yeah? But just showing you guys now so you can see how it works. And then what's the last thing we need to do? There's a 4 here. What do we get rid? How do we get rid of the 4, guys? Divided by 4. So that means when you do 84 divided by 4, 4 goes into 8 2 times, 4 goes into 4 once. So x equals 21, which is correct. The 21st shape, right? Well, you don't need to know how to do that. Okay, not a big deal if you don't. Question 2, right here. The number of bacteria in a colony doubles each day. So let's see, Sarah, can you tell me, from what this question is saying, the number of bacteria doubles each day? What's the common ratio if it's doubling? Good, times 2, easy, okay? And on the first day, so Jacqueline, what's the first term here? First day, there were 300 bacteria. So what's the first term? So here on this question, it says on the first day there were 300. So what's the first term? Good, 300. Not the starting term, all right? The first term. So in this case, state the value of A and R. We know that A, as Jacqueline said, first term 300, and R is 2, as Sarah mentioned. Okay, how many bacteria will there be on the 8th day? You can use your calculator for this and use the nth term. Okay, which is that. Or you can go by hand and use your calculator and just go one number at a time, but I got 38,400. Okay, this one here, on which day will the number be 614,400? Use your calculator. Okay, so using our calculator for this, at what day will, or which term is it going to be at 614,400? So using your calculator for it, you know that the first term is 300, so start with that. So press enter after you write the first number or the starting number. But just remember if it's first term or starting term. So that's the first number. And then Sarah said the common ratio is 2. So you're timesing by 2. Therefore, this is your second number, third, fourth, fifth, sixth, 7. Remember, we're looking for 614,400. So 7, 8, 9, 10, 11, 12. So on the 12th day, we're going to reach 614,400. Okay, this one here, question 3. Now, if you're going to put anything in your bound reference, this is the sort of question you want in there. Okay, because you'll definitely have something in there. Yeah? So question 3 in your revision sheets, you'd most likely have a question like that in there. Margaret started working for a company with a salary of 65 and a guaranteed increase of 9% per year. Okay, so what does that tell you? Well, it's increasing by 9% each year. Right? So what does that mean? Let's see, Lorraine. If it's increasing by 9%, which common ratio rule do we use? Remember, there's 2 of them. There's an increasing one.
The 1 plus.
Yes, the 1 plus. So the 1 plus the percentage over 100. So you want to make sure you use the appropriate one. Read the question properly. Yeah. So it's increasing, so that means we use the 1 plus. The percentage is 9, so it's 9 over 100. And it's 1.09 as a ratio. Remember the rule, if you do increase, if you multiply by a ratio more than 1, the number goes up, and if it's less than 1, it goes down. I like how you look like it did. Okay, it goes down. Alright, so, also one more thing. Tricky thing here is, make sure you read the question. Okay, because if this person starts working on her first year, okay, that means that her first salary, okay, is going to be this, not the starting. Okay, just make sure you read the question properly. This is her first year of work. Okay, so just make sure you understand that. So that means from there, that means instead of using V0, we're going to use the starting term. The first term, because it's her first year at work. Okay, does that make sense? First year at work. Just make sure you understand that. So find, we know the first term is that, and then the ratio is that. Find Margaret's salary for the 25th year of working with the company. Okay, so that means we're looking for the 25th term. Make sure you use the nth term rule for that, because it's a high number. Okay, but that's what I got for it. Well, I'm not using a V0 here, am I? Well, for this one, you need to try and understand how it works. When you start a job, on your first year, is that your first year or is that your starting year at the job? It's your first year. Technically, like when I started working at Lakeview, my salary at my first year job here was like 50 grand. I'm not going to say that's my V0, because it's my first year here. Does that make sense? Okay, so just make sure you understand whether you're using first year or whether you're using starting year, starting term. I mean, at the end of the day, okay, if you have been able to, if you do use first year and use the correct nth term, you'll still get the correct answer anyway, if you think about it. Does that make sense? And if you use starting year, and you use the correct nth term for that, you'll still get the correct answer, regardless. Yes.
Do we put that into the calculator?
Yes.
I'll put it in something else.
What did you put? 25 minus 1? What do you...
Put 65,000 times 1.09.
Yep.
And then with the power of 24.
24?
Yes.
And what did you get?
And I go,
What was that, Emily? Times 1.09.
they give me like 514,000.
To the power of 24. Ah, what did I have then? So if I put 25 minus 1, it should still be right.
Maybe a calculation.
Maybe I put the wrong numbers in. Yeah, that should be 25 minus the 24. All right, well, I did get the wrong numbers then. My bad. Okay, let me fix that up. Do you guys want to know what time I did this?
1 a.m.
Yeah, pretty late. Sorry. That's what happens when you stay up late and you do work that late. Okay, my bad, guys. All right. In which year will her salary be 100,010? Use your calculator for this. Okay, so again, calculator. We know that first term is 65,000. Sorry. So 65 grand. Press enter. Times that by 1.09. So we know that that's already the first term. So second year, third year, fourth, fifth, sixth year. Okay. So on the sixth year, she'll reach $100,010. Easy. Okay. This one here, last one. So a snail starting from the bottom of a drain pipe. Okay. Now here, tricky thing. So starting from the bottom of a drain pipe, climbs 486 centimeters during the first day. Okay, shh, Jacqueline and Alicia, quiet please. Although it does say starting here, it does say here during the first day. Okay, you got to watch out for that. First day, it's 486. Second day or next day, it's 324, and then on the third day, following day, to 216. Okay, so just understand here we're going to use the first term, second term, third term. Yes? Ratio, nice and easy, just any term divided by the previous. If you are unsure as to whether you round it to 1 decimal or 2 decimal, the question should say it in the actual SAC. Okay, whether you're rounding it to 1 or 2 decimals. This is rounded to 2 decimals. Okay, it doesn't say it though, but it should say it. So how far will the snail travel on the 4th day? You can use the nth term rule for that if you wanted to. So if you wanted to use the nth term rule, you can go Tn equals 486 times 0.67 to the power of n minus 1. And we're looking for the 4th day. So this is going to be 4 minus 1. And I got 144 centimeters. Okay, for that one. 144 centimeters. Or you can work it out one by one as well. That also works.
Oh, what did you get?
144 centimeters on the 4th day. Yep, so could be a rounding.
Yeah, okay.
Could be rounding. So, could be rounding because some people probably put 0.66 as the ratio by a lot. Could be. It could be. I think what I so what I would have done here is Torrio would have done this one by one. So he went and done 486. Okay, that's my first term, and I would have gone times, I think 0.67, and he kept pressing enter, and that probably would have been what some people got, right?
Yeah, that's exactly.
Yeah, that's fine as well. I think that's the downside to using either method. Okay, you can go one by one and get this, or if you use the nth term rule and you show the working out. This is the most important thing, guys. In year 11, if this sort of thing happens and you show the working out, they will still give you the mark if you show the working out. Okay, because as long as they see your method. Right, so I'll do the same concept when you do this in for this sack. And then on the fourth day, what's the total climbed after 4 days? Again, this might vary depending on how you added it. Okay, because some people would have gotten like, I think Fatima you got like 1867 or something like that. 1172. Yeah, it all depends on the rounding. Okay, shh. But the most important thing is you show you're working out so that I can see that you've done the correct numbers at least, so I can give you the mark for that. Okay, that's what happens in year 11, especially your exams. In year 12, okay, really, really important that you do show you're working out for that because, again, you don't know who's going to mark your exam. Okay, so you want to make sure you get every mark possible for it. But that's it.
Do you do end term